Right. Well, good afternoon, everyone. Thank you for attending today's webinar on questions from the permit counter. This webinar will be recorded and the recording is posted to the Code Adoption Toolkit, usually within the week or so. If there are any issues with audio, feel free to write me in the chat. My name is Erica DeLello, and I'm a project manager for Noresco. This series is sponsored by the Colorado Energy Office with training materials created by Shamskoda Associates. So Gil and I have been working with CEO to provide trainings just like this one. This is actually the second to last webinar series that we have scheduled. So make sure you attend this one, and then the one coming up is roof ventilation, and Gil will also be teaching. But we will continue to offer technical assistance for jurisdictions that are considering code adoption. We'll continue to offer the helpline support as well. So feel free to reach out to us if you have any questions on that. So most of you might know about the Code Adoption Toolkit and all of the resources available, but today I wanted to highlight the code helpline, and this helpline is available to anyone in Colorado for any of the I codes or reach codes. So if you're a jurisdiction and you need assistance on a plan review, or homeowner or engineer with a question about code applicability, you can submit a ticket, and a subject matter expert like Gil will get back to you in just a few days' time. And you can access this helpline through the Code Adoption Toolkit or through this QR code on the screen. Make sure you bookmark that link. So throughout the webinar, we do want to encourage questions. So please use that Q&A function, and I'll let our presenter know at the end of the presentation. There's also that ability to raise your hand and ask a question, and I can unmute you. And then lastly, there's a survey window that pops up following the webinar. If you could take a moment to provide feedback, we'll continue to improve on these webinars. Today's presenter is Gil Rossmiller. He's been in the construction industry for over 40 years. He was a chief building official for Parker, Colorado from 2003 to 2006. He served on many IRC, IPC, IMC, I'm sure the IECC, all of those development code committees, and is currently working on the Residential Energy Code Development Committee for the 2024 Correlation Committee. So he's a wealth of knowledge, and I'll go ahead and pass it over to you, Gil. It looks like we did have a raised hand from Elvin.
Chuck's saying that for some reason he's seeing, he's not able to use the chat. So can you make sure that everybody can use the chat? I don't know that I've got the ability to use
Yep. Give me 1 second.
Yeah, that's what he put a question in there, I think. Yeah.
All right, you should be set now.
Okay, good. Yeah, he said Chuck said that, so you can lower your hand, Chuck, if you want. That's fine. Should be good.
Okay.
All right.
Good.
Let's see. I need to share my screen. All right. So we've got this. We've got the chat up and going. And I want to see the participants. So, okay. So, hey, everybody, how's it going? Been a while. I'm going to have a little bit of fun today. I've got a few things to kind of go over and questions you may or may not get at the front counter, but this is all about you guys. And those of you that are at the front counter, the old, otherwise known as the first point of contact generally. Aren't you the one answering the phones? And they're at the front counter. It's the old permit tech guys and folks and gals. I mean, I always had the best fun. I always had a great time at the front counter. I don't know. That was not a bad job for me. Okay, let's see. I need to get this here. Oopsie. I need to see this screen. All right. So this is a fun little slide. So this is when folks are coming to the front counter, this is what's already happened. Okay. So they've dreamed about their project. They've designed their project, and now they're ready to go, ready to get their stuff done. Yeah. And so they're excited and they're ready to go. And the wonderful thing about being at the front counter is that we can have wonderful conversations about what their project is and what's going on and all kinds of fun stuff. So type into the chat, what are we doing? You know, what's our overall job as code compliance or code enforcement type folk, right? What is it we do? Right? What is it we do? Stare at the ceiling and stuff? Customer service, Jenny, yeah, good. John, yeah, customer service, sure, absolutely. And I don't know, let's think about, you know, what part of that customer service piece is, right? Provide resources. Emily, very good. Yes, I like that. Yes. Yeah, we're here to educate. We're here to provide, you know, compliance with the codes, life safety, all that kind of stuff. Give options. Yeah, communicate, educate, provide answers, helping them succeed by using the codes. Gosh, you guys are awesome. Yeah, how the code applies. Actually, guys, you know what our job is? Our job is to crush dreams. Yes, that's what we do. Yes. Clearly, I'm jesting, right? But the idea is, with all of the things that you've just done, I know, isn't that, I know, make everybody cry. I know, that's what we didn't really want to say that, but provide reality. That's exactly right, Kevin. The idea is all of wonderful recommendations, wonderful answers, because you're absolutely correct. The idea is that when it's on paper, okay, it's easy to change. It's easy, okay? Before the projects get started, you know, as a code consultant, that's half my battle. It says, I'm trying to find what will kill this project. What did they not think about before we've even put a shovel in the ground, okay? Because it's a whole lot cheaper now than it is in the end, okay? And so the beauty of being at the front counter and having those conversations is all of the things that you just said, right? But sometimes you're right. You get to a point that says, oh my gosh, I had no idea we had to do that. Yeah, and here's why, and you provide the handouts and you provide the education. So that they understand that it's not just something we're making up, and that there's actually a reason behind it. So you guys are awesome. Those were wonderful things. So anyway, that's just fun. That's just fun stuff. So some of the basics, we'll just hit some basics here. But anytime you've got a question, don't let me go by something that you don't understand, or a document that I might look at. They don't understand, just pop up, put your hand up, and we'll get it taken care of. Okay. All right. So just a few quick energy code related type definitions, because a lot of times people comes to, you need to have to be able to speak the language, right? And then understand what it is what that is, right? So we'll hit a little bit of, so these are all residential definitions, but it's essentially the same sort of for commercial stuff. We won't get into a lot of commercial stuff today, but we talk about air barriers all the time, right? And what the heck is it? Well, this is the definition out of the residential code. Just talks about one or more materials that basically blocks air, okay? Now, typically, you're going to see some assemblies like a water-resistant barrier, you know, like Tyvek. People are familiar with that kind of a house wrap, Tyvek. That could be an air barrier, but it has to have specific installation requirements in order for it to be that way. Typically, you're going to see air barriers as rigid type material, like thermoply, That's just really thin, cardboard-like stuff they can use for structure at times. They used to use it all the time, but not much. OSB would be another one. Sheet foam, foam, 1 inch thick foam, half-inch thick foam. That would be that stuff that's got the, the tin foil on one side, right? It's got shiny surface on one side. Those could be air barriers. So that's what that's all about. Because as we talk about energy code, air coming in and through the walls is not good. And we'll have a couple examples and talk about why that's important. Okay, next slide. Good old BTU. Yes. Talk about BTUs all the time. The old British thermal unit. Yeah. So the definition is, the amount of heat required to raise 1 pound of water, 1 degree Fahrenheit. That's how it is. So we talk about BTUs, BTUH, BTUs per hour. Okay. You're going to see a lot of those things in your HVAC designs. All right. How big does the furnace need to be? How many BTUs does it need to have? And cooling, same thing, right? Got heat gain, cooling, and heat loss. Heating, right? Yeah. So those are all going to be in BTUs. Okay. Yeah. And then one of the biggest pieces in this whole energy code business is to understand when we're applying the residential energy code requirements and when do we apply commercial energy code requirements, because it can be confusing. So there's the definition. All right, for this code, energy code, IECC, includes detached 1 and 2 family dwellings and townhomes, anything that's built out of the IRC. Okay, that's those first 3 statements. Single and 2 family dwellings and townhomes, anything out of the IRC, all residential energy. Then it says, as well as groups R2s, R3s, and R4s, buildings 3 stories or less in height above grade plane. So the picture you're looking at right there, let's see, let's get a little pointer. Yeah, so we've got first floor, happens to be a garage, probably some living space, back here somewhere, but 1, 2, 3. But this would not be built out of the IRC, would it? This would be a commercial building. This is where it gets that little bit of, confusion about what's what. Yeah. So we got an R2 building there, assuming that's an apartment building. That's an apartment building. Okay, so that'd be an R2. R3 would be like a single family, or the definition is a 2 or few dwelling units in a building. And so that's when it would be an R3 if you're building it out of the IBC. R4s, it's going to be kind of a group home kind of an environment, but that would apply. So that would all be residential energy. And the beauty of it is, if it's not a residential building, if it does not meet this definition, it's a commercial building. Yeah, because definition of commercial building is when it's not residential. It's pretty simple. Yeah. Yeah, so the idea is with the counter, it's just like, well, we've got ourselves a comm check here, and you realize that it's a 1-story building. No, it won't be that. It's residential, R2, R3, or an R4. That'll be a res check. That won't be a comm check. Just had that conversation 3 minutes ago before we started this class. Yeah. So just recognizing when it's residential, when it's commercial is a good delineation, because there are a lot of folks that don't get that. What the heck is R value? Well, right, it's right. A material's resistance to conductive heat flow, right? Yeah. Is measured at a rate of its thermal resistance, or R value. Yes. So how does insulation insulate? Yeah. And it doesn't matter what kind it is. So you have 2 basic types. You hear the term air permeable type insulation. Air permeable type would be fiberglass bats, blown in bat, like this picture here. That's what we'd call blown in bat. It's fiberglass, just blown in. Cellulose would be another, there's blue jeans. You've seen the blown in blue jean stuff. That would all be air permeable, meaning air moves through it. Then you have air impermeable. Air doesn't move through it, like foam products, okay? But they all work the same way. Insulation works by trapping pockets of stagnant air, okay? That's a key. So when you think about insulation, back in the day when we just had 2x4 walls, you could get batt insulation that would fit in 3.5 inches, okay? And it could be, you could get it for an R11, you could get it for an R13, and you could get it for an R15. And the difference is that the batts now, or the composition of the batts, is getting denser and denser. And so what's happening is that we're getting smaller and more pockets of trapped stagnant air. That's what makes insulation work. The same thing happens with the foams. So the spray and foam that you see that people do, the spray applied or the sheet goods, works the same way. It's just that the pockets of stagnant air are microscopic. We can't see them. That's how it's manufactured. But it works the same way. That's why, closed cell foam, for instance, you can get about an R6 per inch, which is pretty intense. That's a lot. Open cell, it's more like fiberglass. It's more like fiberglass. It's very, very vapor open. Still an air barrier. Air barrier itself. Foams could be air barriers themselves at certain thicknesses. So this kind of gets back to our conversation about air barriers and how, why within the IRC or within the residential pieces, we've got a whole lot of air barrier type requirements. Okay, and we're going to look at a couple of details later here. But the intent here is that we just described how air permeable insulation works by trapping air. Okay. Well, what happens when air is allowed to move through it? That's the problem. So for those of us and anybody that's actually done a remodeling project or seeing someone do a remodeling project on an older home, you tear the walls out, and for whatever reason, when you look at the insulation, it's just full of dirt. You could literally pick it up and shake it, and the dust and the debris would just fall out of it. And you think, what the heck? What is that all about? Well, it's because air was allowed to move through it. Yeah, older houses were very leaky. It's why it's so important that things are very, very airtight, along with other, many other health reasons. There's all kinds of stuff. But if you allow the air to move through, you got a pressure differential, but through the fiberglass, it ain't gonna work. It's just gonna get full of dirt. And a few years later, not working like it's supposed to, right? All right. U factor. What in the world? Now we had R. So what the heck is this? So we have all kinds of different ways to measure resistance to heat flow. U factor, I'm not going to read you the definition because you're just like, huh? What? It's basically a formula. But what it is it's the entire assembly. So and let's take a look. We'll look at an example, very simple example. When we talk about the U factors, we're talking about the overall resistance to heat flow for an assembly, not just one piece, okay? So we just talked about R values in fiberglass insulation. So let's go back. Let's go back one slide or two slides. So when we look at this wall assembly, we can tell you what the cavity insulation is in here because you can see the studs. Yes, I'm sure everybody's going, yes, Gil, we can see the studs. So that cavity is going to have an R value. Whatever the R value per inch is, if it's a 3.5 or 5.5 inch wall, it'll give you right? Your R, your R17, your R23, whatever it might be. But now when we talk about U factor, the insulation isn't the only thing making up this wall, is it? And then we have these studs, okay? It's called the thermal bypass because there's no insulation there. There's no cavity insulation where a stud's at. And so we have a calculation called this U factor for the assembly. And this is what it would look like. Okay? It's very simple. It's just a simple example, 2x4 wall, nothing fancy, but this is how they're all done. Okay? We've got something we call air films, and they do have an R value. So the rule is that you can add R values, but you can't add U factors, U values. We'll show you how that works. So we've got two different columns that we're going to have here. We're going to have what the insulation value, what the value is at the insulation, cavity insulation, and what the R value is at the stud. Okay. So we're going to start with this outside air film, and we've got the same, and we get this from the ASHRAE Book of Fundamentals. Not that we're going to get into that too deep, but a very good number. Then we've got some plywood siding, could be lap siding, could be lots of different stuff, stucco, brick, all kinds. It has an R value because it's continuous. The air film is continuous over the stud, so is the plywood siding, and so is my half-inch wood sheathing. It's continuous over the studs. Hopefully you can imagine that, yes. Then on this particular example, I actually put in 1 inch of insulation on the outside. So it's sheet insulation, it's continuous across the studs. And then in this example, I just said we had an R13 batt, or it's the stud. So we're gonna have R13 at the cavity, but a wood stud, 3.5 inch wood stud's only about an R3.5. And then we come down the list to gypsum board and air film up on the inside, which is continuous. All of those are. Then we get into the calculation, how this is done. Now we got to decide, well, how much of the wall is wood, right? How many, we have headers, right? We've got studs, we've got all kinds of different plates, top plates, all kinds of stuff. For this example, we're just going to say 20% of the wall is wood and 80% of it's insulation, cavities. We just do the math. We added up our totals here. So we had an R19.27 at the insulation, and we had an R10 at the studs. Yeah, so we just 80% of the wall was at R19, 20% of the wall is at R10. We do the math, add them together. We have what we call an effective R value of a little over 17. And to get the U factor, they're reciprocal of each other. So 1 divided by the R value is the U factor, and vice versa. 1 divided by the U factor gives you your R value. Yeah. So all assemblies are done like that. That's why when we look at windows, right? Windows, it just say, oh, well, the windows in climate zone 5 and the 21's got to be what? 0.3? You have to have a use factor of a 0.3. Well, we have to do an analysis on all the pieces to that assembly, correct? So we have glass, right? We've got the spacers, the little spacers that put the glass together, the thermal panes. And then, of course, there's the frame itself, the sashes, the wood frame or the vinyl frame itself. Does it have the little grids inside the window? All of those things then are calculated to give what is the overall U factor or resistance to heat flow for that assembly. So it's all in there, and we'll show you. We'll show you. Okay? I know. Technical stuff, huh? Wow. Then we get into this concept of the building's thermal envelope. Well, what the heck is that? Well, it's required on the plans. It's required. The idea is that what are we trying to heat and condition and what are we not? Okay? Believe me, the architect, I just took this off a relatively recent set of plans. So here's the definition. And it's essentially, hey, what are we conditioning and what are we not? In this particular case, we've got a really good indication, especially in this one, that the roof doesn't have a vented attic. This looks like it's going to have an unvented attic assembly. So it's very clear what, the plans examiner needs to look at. Okay, some flat roofs. You got walls. We got basement walls, a little concrete slab, right? So adding this to the designer's plan is just not particularly difficult at all because they've already done the building section. They've done the sections, they've done the plan views, they've done it all. All they do is add a little dashed line because it's already done. Really helps plans examiners and really helps folks when they go into areas. What am I insulating? What am I not? What's a floor? What's a roof? What's a wall? Yeah, because we got different requirements for that, don't we? And then a fenestration, we hear that word all the time. Oh, fenestrations, the windows and the doors. So what they've got here is, we've got a definition here, products classified as vertical or fenestrations or skylights. Holes in the wall. Right, then we've got glass and transparent, it says blah, 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 less than 60 degrees from horizontal. Yeah, so unit skylights, tubular daylighting devices, another unique business. Yeah, we got sunrooms, all kinds of stuff. So good old protractor. When was the last time you saw a protractor? Come on. Yeah, so all this is saying is that from less than 60 degrees to here. So if the roof is anywhere in this from here to here, it's a skylight. Different requirements for skylights. And then vertical, just the opposite. If it's more than, right? More, not less than 60 degrees. So we're going from 90 to 60 degrees. We're going to be right in here. Well, I guess it could go down over to here, right? 120. But yeah, generally walls are vertical. Yeah, but notice the fenestrations or windows are fixed or operable, opaque doors, right? Opaque door, glazed doors, glazed glass block. Yeah, glazed block. Yeah. Glass block you can see through. Sure. Yeah, and then you got combination glazed, opaque, and glazed doors. So the idea is that all of those are going to be a 0.3 because it's fenestration. All of them, whether they got glass or not. Yeah, we've been talking about this. This has changed. The definitions have changed, from here to there. But this is the latest one. High efficacy lamps. Now it's 100% in the old 2021 for residential folk. LEDs make it. All this stuff. LEDs have pretty much taken over the planet. It seems like you're not going to be able to get the incandescents anymore. I still think compact fluorescents meet this. Some of them, T8s and smaller. Yeah, they're probably getting pretty close not making this fluorescent bulbs. So what do we got? When we're talking at the front counter and people are asking questions, what do we need to know? Well, you should really know what your current adopted codes are and what the amendments are. That should be a wonderful handout. You guys, I'm sure, have got all kinds of wonderful handouts for that. Okay. What needs to be shown on the plans? And we'll show you the list, and we'll kind of go through what that looks like. But what are they doing? Because each one of these has its own little requirements and its own little report, and how we're going to be showing them on the plans. Okay? So really simple questions like, okay, well, we're going to go prescriptive. Oh, okay, good. So were you going to do that U factor table? Were you going to do that R value alternative? Or were you going to trade everything off in the thermal envelope there and do the total UA? Did you give us a res check, or did you not need a res check? Yeah, you don't have to have a res check, right? We're going to look at the simulated performance path and what that looks like in the documents you need. And what that entails. Energy Rating Index, ERI. We'll take a look quickly at one of those little reports and what that looks like. And thermal envelope, there's the section numbers. These are all the different section numbers. These are all 21 IECC section numbers. And the old additional energy efficiencies. Yes. Don't have a choice. Those you get to do along with everything else. So section 103 R 103.2 says this is what you need to have on the plans. We're going to go through each one of these so you understand what they are and what they look like. If you end up looking through plans, right? There's some jurisdictions that make you sit down with a set of plans and you sit down with somebody and you flip through the pages to make sure they got all the stuff on there. Right. And you got other jurisdictions that say, well, as long as you tell me you got it, we'll just let the plans examiner figure it out. Okay. I kind of prefer the at least get the basics, right? So we can at least have some place to start rather than it's like, well, you didn't give me everything I need for the performance path. I can't tell you. You only gave me half of what I need. Yeah. So maybe a little checklist saying, hey, right? Did you provide it? Let them dig themselves a hole, right? Yeah, it's in there, even though it may not be. Yeah. So what are the what are those paths? Okay. Well, what the heck are they? Well, here's the first one. This is this U factor table. So what this is that assembly U factor. So that little wall that we went through, yeah, this little wall thing, that's this table. Yeah. So the equivalent assembly U factor based, and it is, I don't want to say it comes from, is how then the R value table is created. Okay. So this is kind of like the base table. It always really has been, and they finally got it figured out that we should put it first. Okay. This is where everything starts from. Okay. And when we talk about this U factor table or the U factor alternative, this is what the assemblies need to be. Climate Zone 5, just picking that one out. And the engineer or whoever could do the calc. I mean, they won't give you a picture of the wall. It'll probably just be more a diatribe, a description of the wall and the values that they used for it, but they could calculate the U factor for the wall that they are putting in or the assembly they're putting in. They certainly could. Okay. You don't see it very often. It wouldn't look like this, but it's the same kind of thing, right? So then we get to this U, or this is this R value alternative. These now are based on what you need to have so that the U factors make sense. So let's do something for fun. Who's got a calculator with them right there with them? I mean, who has a phone? Who has a phone? Let's take wood frame. Well, let's see. Let's take something that's a little bit easier. Yeah, let's do that. I want you to take a look at this, and we're going to look at the ceiling U factor. Okay. What I want you to do is we're going to do a little bit of math that we just learned, and we're going to go ahead and say we're going to take 1 and we're going to divide it by 0.024. And what do you get for an answer? You get a bill all over it. 41.66. Absolutely correct. Very good. Then why does the R value table say R60? What's that all about? Yeah, 41.67. Yeah, you round up. Good for you, Jenny. That's right. That's right. That's what you do. It's above 5 or above. You round up. Perfectly acceptable. Bill, I love it. Because they like to mess with us. Punishment for using the R value table. No, it actually isn't a punishment. So I use this as an example because it's something that we need to be aware of. Okay. So remember the example we went through with the wall? Remember how we had R13 insulation, but do the math on that, right? Should have done it. You're going to find that U factor, that 0.056 is an R13. Remember, we got less than that. And so what this is happening, so I brought the ceiling in. So for those of you that are into the IRC and know framing and know all that stuff, what is the required truss heel height? So what is on the trusses, where the trusses come down and sit on the exterior wall, okay? Even roof joists or rafters. What is oh, Joey, instant, is that Jose Burkett? I'm probably completely butchering your name. Right there, 12 inches. He's there, 12 inches. Anybody want to agree with that in the IRC? 12 inches is the minimum heel height. And I'm talking about the code as written, not maybe anybody's amendments, okay? What is it? Bill, I'll agree. He's there. I love it. Both are wrong. Anybody else want to guess? There is no required heel height. It's whatever it is. Yes. Yeah. So even though we might say it's an R60, what happens if yep, Heather, absolutely, yep, absolutely good. Even though it says R60, it's making the grand assumption that it's coming down to maybe 3.5 inches, right? The bottom cord. Well, you ain't got no R60 all the way around the edge of the building. It's terrible. Hey, that's one reason. Plus, you're going to have webs. You're going to have some thermal bypass there. It's not going to be perfect continuous, very close, but it's going to be like that. Yeah. Now there's that section in the code, remember, that says, hey, if R60 is required, well, you're going to have baffles for sure. Absolutely, Chuck. So when you get into that section, yeah, Robbie told us it's about 16 inches. Well, I'm going to tell you right now, if they're doing, just a word to the wise, okay? If you're getting performance pieces or total UA pieces from the performance software, the Ecotrope stuff, I'm going to tell you right now, you better have heel heights that are as high as an R60 insulation. Otherwise, it doesn't work. So I don't know what R60 is, 24 inches, maybe 20, 24. I have no clue, depending on whether you're using cellulose or blown in bat. But it best be that same heel height. Okay. Well, that's a class for later. I won't be able to get to today. But what I'm saying is that in the residential code, there is no requirement for a heel height. The only time you're going to get requirement for a heel height is a section in the energy code where it says, hey, if it requires R60, if you provide a heel height for a minimum of R49 that goes over the entire width of the exterior wall, then the entire attic can be R49, okay? That is the only place that I'm aware of, and if anybody else knows better, please let me know, because I hate to lie. I hate to be uninformed, ignorant of the fact that I didn't know a code section, which is quite likely, hopefully not very likely. So yeah, that's why. And you're going to find the same thing with all these other too. You could look at the floor R value at R30 and go back to the U factor table. So yeah, 16 inches is R49. There you go. So it's going to be, you're probably talking 20, 24 inches somewhere in that area for R60. Yeah, take a look at that. We can do that. But yeah, they're doing a performance path. I can guarantee you, especially if you're getting a performance path in the 21 and they're not using continuous insulation on the outside and not providing an R30, right? So look at this. you got to have continuous insulation. The only one that isn't is cavity only, and climate zone 5 is R30 walls, 30 cavity. Yeah, I haven't seen that yet, but I've seen plenty come in with an R23 or an R28 wall blown in like foam. Yeah, you'd have to go to 2x8s probably. I don't think even closed cell foam would get to 30 and 5.5 inches. But I can tell you right now that they're using the correct, because when they're using the performance path, yeah, I've got a couple seconds here. These are the reference house U factors they're using in the calculation. It comes right from this table. It's the requirement. Okay. Well, I can tell you, because we just did the math and it's only an R41, they're giving them close to an R60 in the performance evaluations, because theoretically they're putting in high heel trusses. Yes, sirree, Bob. You're not getting that deduction. Otherwise, they would nick them. They would discount the energy used for that. Okay, moving on. So we can get out of here in relative equal time or on time. R value alternative. Yeah, so basically we just need to have something in the plan that says what we're doing. Okay. This is just a quick shot off a set of plans I had. Personally, I would much rather not, this looks like the 2018 code. I would much rather have them tell me what they're doing. What are you doing with this house? I don't want to see what the code says and all the different options that you could have. Okay. Yeah, I already know what the code says. Right? I don't need to know that. What I do need to know is what it is that you plan on doing. Because if they're doing the performance path, they can do whatever it is they want, right? It has nothing to do with the prescriptive table at all. So tell me what you're actually doing in the plan. This is just a sample. This is a total UA. This is a ResCheck. They could actually do the math themselves, but ResCheck makes it so much simpler, right? Quick checks for you guys at the front counter. Is it the right code? Is it the right town, right? And did it pass or not? Then move on with life, right? Let the plans examiner make sure if all the entries were correct. Performance. This is what it'll say. At plan review or at your front counter, when you're first submitting plans, it'll say 220 performance compliance. Now, this is just the first page of many, many pages, okay? But essentially, hey, is it the right property, and who did it and that kind of thing, right? In your right spot, is it the right code? The thing that you don't get, you're going to get two different reports. You're going to get one, and this is telling me the house that they built, and you're going to get another report that is the reference house. The reference house is the code built house that the house being built is compared to, and does it use more energy or not? Yeah, so you need to have both of those reports when they're doing performance, so you can double check, make sure that what they're doing is that right. Can they manipulate it? Yeah, most of them won't, but it just keeps them honest, right? So performance is the cost, the energy cost for heating, cooling, water heating, and whole house ventilation. That's it. You don't look at all these down here. All you do is look at this. And if this number here is the same or less than this number here, it passes. A review for another day. Okay. It's important you get both. 9 times out of 10, I'd almost have to say 100%. You never get the reference house report. You almost have to ask for it during review, or it's like, part of your handout says, make sure you get the as-built house and the reference house report, please. ERI, not going to get into the details. The report looks a whole lot like the one that we just looked at, except it says ERI, Energy Rating Index. Yeah. So you don't take a performance report or a res check or anything like that for ERI. It'll actually say right there. And it's just based on numbers, right? You can look at a table that says, the numbers. So you're just looking at, is it in the right spot, in the right address, right builder. Depiction of the thermal envelope, just another one, just in plan view, right? So it's pretty easy. Dry it around, see what they're doing. Makes it simple, makes it so simple for these guys to do that. And then we've got all the enhanced additional energy efficiency options. Not going to go through each and every one, but they need to do one. And did they note it on the plans? And did they say this is how we're going to find compliance with it or not? Right? Crystal looks like I had a question. It says, for the ERI option, why have an additional efficiency measure? Why not just a table of 5 better in color? Good. Well, if we have time, we'll take a look at that. But there is an exception for performance and ERI and additional energy efficiency pieces. If you're doing the prescriptive, right, one of the three, prescriptively, the U vector or res check or the R value alternative, then you have to do it. Okay. But I don't know if we'll have time to get into that. But you're right, Crystal, there are some times where it's got to be just a little bit more efficient and then you don't have to deal with it. But if we have time, we'll open up the code and take a peek at that quick. Okay. So we got enhanced envelope stuff. So, higher R values, more efficient HVAC, right? Higher than the federally required minimum, greater than a 78 or an 80% furnace. Service, reduced energy and service heating, water heating. It's water heaters. Thermal distribution ducts. Yeah, most of them, a lot of guys will qualify for this one. Just from what you're doing. So if your furnace and your heating and air conditioning equipment and all the ductwork is within the building's thermal envelope, that's what this one is. Yeah, that's what that one is. Yeah, improved air sealing and efficient ventilation. So I think that one has, you're getting a tighter house, better ACH 50 or CFM per square foot. So I guess you put it, we're not required to do that here. Yeah, it seems like if I got to do an extra 5% already. Yeah. Well, look, now that you've asked and I've put that statement there, you got me guessing. We should have a minute or two to do that. All right, so we went. Well, those are what the plans required. Let's get through this stuff here. What am I doing? Where am I at? What's going on? Okay, so here we go. Number 3 was Windows. So let's get a U factor or a solar heat gain coefficient will be under Windows. You need to have them on the plans. Area weighted averages you're not going to see very often. 9 times out of 10, that's not an issue, but this is just a simple calc and how it's done, right? So if I've got 7.31, there's 100 square feet there, and some are 0.41, and I got 100 square feet, and some of it are 0.32, and I got 100 square feet, right? You just do the averages. Take that, add it all up, divide it by the total area, and then you get an average, okay? An average, weighted area average, and I can't remember what the lowest you can do. It seems to me 0.4 was for solar heat gain coefficient. Can't remember what it is for U factor off the top of my head. Mechanical design, big deal, really big deal, right? We should be getting some sort of manual J, S, and D in there. This is just one little sheet off of that. So having what you guys are requiring is good. And if you haven't filled this table out, that's the 21 table. Everybody fills this one out because it's been there forever. But this is out of chapter 3. I filled in some here that don't change. That's what it is for everybody. Doesn't matter where you're at. Okay. But all of these, of course, change your elevation, where you're at, latitude, and correction factor, and design, all of this stuff, right? Changes based on your weather. So it's good to get this filled out. So the guys know what to do. Yeah, and the size, you're gonna have it here, you're gonna have controls, efficiencies, it's all gonna be also, it's also gonna be here on the manual J, part of the manual S. You're gonna have all of that stuff there. Based on those, yeah, controls, how's it working? Gonna have a thermostat, do we have radiant heat floors, do we have radiant heat, do we have snow melt systems, are we heating outside the building? Right, what are we doing? You gotta have controls for it. Now, this is just from a mechanical plan, talking about setbacks and where they're going to be setting the heating and cooling at. Insulation, are the ducts inside or outside the building thermal envelope, and are they going to have insulation on based on where it's at? Okay, going to have that in there. And then we got all kinds of air sealing details. Did not, just giving you one here, but this is a nice little detail about soffits. Yeah. Yeah. What's my conditioned space? What's not? Where's it going to get sealed? Right? Solid. So could be anything. The sheetrock could be OSB, lots of stuff. Keep the air moving through the walls. Commercial, not going to get a ton of this stuff, but it's essentially the same kind of questions. Yeah. Right? And the amendments and the paths are a little bit different. And a lot more intense and a whole lot more information. Yeah. Got U factor, we got the R value, and then we got the component performance alternative is essentially the total UA for commercial buildings. And that generally a ComCheck will handle that. All of these other things then you get to do prescriptively, right? Mechanical systems, a whole chapter, surface water heating, electrical power and lighting systems. Oh my goodness sakes. You got additional efficiency requirements here. And this is a biggie. Maintenance information and commissioning. Once the system's in, how's it supposed to work? Right? That's for the maintenance folk. And then commissioning is like, well, we got to put in, does it really work? Is it there? Does it work? Right? Then you get to performance. Yeah. So you can do any of this or performance or ASHRAE 90.1. I believe it's a 2019 edition. Yeah, a whole different piece. Not even going to get into that today, right? Same thing, description of the depiction of the thermal envelope. The list that's got to be on there looks a lot like what we just did in residential stuff. Yeah, fenestration and weighted averages and design. Economizers, that's just part of the HVAC system. That's what lets the outside air in when it's cool enough to cool it off for air conditioning, right? It's 65 degrees out. You don't need to run the air conditioner to cool the building down, do you? Right. And then duct sealing and fan horsepower, that's just for bigger motors. Yeah, and air barrier sealing details, location of the air barrier, and commercial, it's a lot different. Not going to get into it today. And the slide that we looked at in the very beginning, and this is me. So don't hesitate to give me a nudge if you've got a question. And let's see, that's not what I wanted. We wanted quickly to see 21. Let's see what this says. All right, so what we've done now in the 21, because before, remember, we had little parentheses in the prescriptive where you'd have parentheses and it would say mandatory, the section's mandatory, and others would say prescriptive, and everybody was confused about, well, what do we do for what? Well, now in the building performance and the ERI paths, we simply have a table that says, okay, you're going to do everything that's in 407 for performance and all of these other sections. Okay. All of these other sections. Am I, where am I at? Okay, I'm gonna see, let me get to residential. We did the same thing in residential, sorry. All right. Building performance, okay, so here we are in residential. So the same pieces. So when you get down here, we do not have R408. So you don't have to do any of that stuff. Yeah, that's correct, Chuck. He's reminding me that I don't work on Fridays anymore. Gil's a 4-day-a-week guy, Monday through Thursday. Yeah, so it's not, and it used to say 95%, but yeah, so no, it is not there. Yeah, and it just goes into the reports. All the blue stuff is new for 21. And then the calculation procedure and everything that you've got to do for that. So there you are. Not required. Cool. Any other questions? I know we're getting a couple of minutes here. What do we got? Questions, thoughts, answers. Here, I'll let you see this. You got my email. Anything I said that was just so totally outrageous and is completely wrong? No, nothing. I'm not seeing anything. Good, bad, or indifferent.
Thanks, Gil.
Sure, Erica.
I also
Yeah.
post in the chat the code adoption toolkit, so you can access that helpline that I mentioned earlier there, or the recordings. So thanks, Gil, for a great presentation. We've got 2 minutes left though. Any additional questions? I'm gonna go ahead and stop the recording.